Let's take a look at what an exponential function is. So before we do that, an exponent is if I have a number in a base, an exponent is the number that is to the power. So if I were to try and figure out what 4 squared is, that means 4 times 4, or 16. If you want to, you can have that exponent be anything you want. You can even have it be a fraction. So 4 to the 1/2 power would be 2. Or you can even have it be a decimal, maybe 3.71. 4 to the 3.71 is a little bit more tricky to calculate. You would need a calculator to calculate that out. So on my calculator, I calculated 4 to the 3.71 out, and I get 171.25. Now this isn't an exact equals, it's an estimate because I rounded it. So we'll do an estimation. All right, these numbers down here are called the base, and then you have up here the exponent. So now that we know what an exponent is, let's take a look at exponential functions. An exponential function is where I have a function that equals a number in the base and then an exponent in the power. So let's say I have f of x equals 3 to the x power. My base here would be 3 and the exponent is x. We can actually do a t-chart to calculate or find the functions here. So if I wanted to go and plug -2 into my exponent, it would be 3 to the -2 power, which would be 1/9. If I want to plug in 0 into my exponential function, 3 to the 0 equals 1. If I want to plug in 1 to my exponential function, I have 3 to the first power is 3. And let's try another extreme one. Let's go like 5. That would be 3 to the 5th power, and that is 243. So oftentimes you'll hear an expression, something's getting exponentially bigger. That means these functions. So if you start out with 3 to the first, you're at 3. So maybe 1, 2, 3. But then 3 to the 5th is going to be way off the page. These get exponentially big really fast. So essentially, an exponential function is a function that has a number in the base and then the variable is in the power. Let's take a look at a real world example that involves exponential functions. The population of a city is 250,342. The city grows at a rate of 1.2%. The exponential function is represented as f of x equals 250,342 e to the 0.012x, where x is the number of years. Find the population after 10 years. So what that is asking is, if you have a function here, f of x equals 250,342 e to the 0.012x power. You want to find the population after 10 years. What that means is to plug 10 in for x. So we would have f of 10 is equal to 250,342 times e, which is a number that's on your calculator. It just represents the natural number. E to the 0.012 times 10. And you actually just calculate that out on your calculator. Alright, so I calculated this out on my calculator. A lot of times your calculator will have a button that looks like that, e to the x, or e to the y, or e to the x, or e to the y, anything like that. And you just press that button and then type in your power. On your cell phones, if you are going to use a cell phone calculator, which I would never really recommend, you usually need to type the power in first and then press the E to the X button. Okay, but in this case, we just type it all in. If it's a good calculator that does order of operations especially, and you get 282,259.8. Now, since you can't have 0.8 of a person, technically that's not wrong because it's like a projection of what it should be, but you can round to the nearest person. So that would be 60 people. And there's our final answer.